This is Brett Farkas, the author and programmer of Old King Graham. I wanted to talk about voice recognition gaming and programming, both generally and specifically. For the text boxes on the screen, there's always a white box right behind it so that you can read the words more easily. And I wrote some code to dynamically size that box. And so, based on the amount of text that a certain character is going to say, I looked at the amount of words and just kind of roughly estimated how large the box would need to be for each line and sized it like that. So each white text box behind some text is slightly different from screen to screen or from sentence to sentence. And I had the code take care of all that, so I didn't have to size each one individually, which would have been a huge task. And right here, I had to swap in an image to make the main character face left because I wanted him looking at the queen. And so there were certain key points in the game where I had to position the character once he got to a certain location, so I just swapped in the image that I wanted. At this point in time, most gamers have never played a voice recognition game. The whole genre is still in its infancy. I think the adventure game genre is the best application of this technology. If you go back and study the games designed by the Sierra Company, they were really ahead of their time with this type of design. Back in the 1980s, they were making these text parser games where you had all this interactivity. You could pick up items, you could use them in creative ways, you could talk to people. And the thing that's great about that type of system is that your interactivity with the game is not limited to a few button presses, right? You're only limited by your vocabulary, and so it opens up potentially thousands of possibilities on each screen that you're on. And what I found is that my imagination would light up on every screen because you see all these items and you think, maybe I could do this, maybe you could do that, maybe you could combine these things. It really allows for a degree of creativity which most gaming doesn't allow. In this particular game, you can tell the main character where to go, and there's several different ways of doing that. You can talk to other characters. You can sometimes pick up items, and you could use items as well. For the walking system, I came up with a solution that maybe wasn't the ideal solution, and I think going forward I would do something slightly different. So I programmed this game in HTML from the ground up, so not using a game engine. It's around 10,000 lines of code. Did the whole thing in about a month. And so on each screen there are boundaries set up, rectangular boundaries. There aren't any smooth curves or anything like that. Everything is right angles. And I programmed it so there are certain destinations you can go to. And so you might tell the character to go to a door or something like that, and I have the X and Y coordinates of the door programmed in. And at that point, the character knows what the destination is, and I also programmed in a navigation system that is universal. So this navigation system applies to every single screen in the game. And so, for example, if the character is walking from left to right, and let's say there's an obstacle in the way, the code will look at that object that's blocking the main character, and it will calculate the distance to walk above that object, and it will also calculate the distance to walk below that object. And whichever distance is shorter, the character will take that route, and when it passes that obstacle, it will turn in the direction of the obstacle until it gets to the right X coordinate, at which point the character will turn up or down. And so you can imagine the character taking a U-shaped route to get to their destination. The thing to keep in mind with navigation programming is that the mathematically ideal route that a character could take is not necessarily the same way that a human would control the character. And so when you're moving the character, you don't want to move it the best way possible. You want to move it in the most natural feeling way possible so that it seems right. So for example, when you're walking around in your house, and let's say you're walking around a coffee table or something, you don't walk right up to the coffee table within 1 millimeter of it and walk at a perfect right angle within 1 millimeter of the coffee table and perfectly navigate around it like that. You generally keep your distance from objects, but in retrospect, I think a better way to go about it, instead of making a big complex navigation system that works for everything, it probably would have been better to be more specific and for each screen to have certain waypoints that a character can go to. And I think it's important that a character is able to move around on the screen away from predefined waypoints. And so that if you tell a character to go left or right, I believe the player should have the freedom to have the character go wherever they want. And so if you tell it to go left, it should be able to go left. But I still think if you say, like, go to the door, there should be specific waypoints along the way to that door that feel like a natural path that the character is going to hit. And that way it feels like they're moving in a natural way. So you could program it so the player always has freedom to go wherever they want. But if they do say, walk to that door, the character is going to walk to the nearest waypoint. And at that point, they'll follow a natural path to that door. I think it's important to give the player as much freedom as possible with this type of gaming. I set it up so that each screen in the game has its own set of keywords that you can hit. So in a specific room, if there's a 4-leaf clover on the ground, I've got the word clover or maybe plant in there as a keyword to activate a certain action to trigger some text on the screen, right? And so I split it up for each screen. So basically each screen has its own vocabulary that can be accessed by the player. And if someone triggers one of those keywords, it's going to trigger a certain response from the game. This is in opposition to the way that I know Sierra did their text parser, where they had certain keywords that were universal for the whole game. And so in the code, if you said look, there was a whole look system that would be activated. And then afterwards, it would look for the specific location of the player and fetch up all the relevant text or actions based on that. Whereas in my system, I went to the screen first and then looked for keywords after that. So I split up the code that way. I had to do my best to guess what the player would think to say on a given screen, which is kind of tough to do because everyone has their own cultural background, so everyone's going to have their own way they think about things or interpret things. Everyone's going to have their own unique vocabulary that comes to mind, and so I tried to put in as many synonyms as possible. So if you have a key on the ground, you could look for the word key, but maybe they won't know what it is exactly, and they'll call it a yellow thing or something like that. So I think ideally in the testing phase of the game, you'd be able to look at all the potential responses that your testers were saying and plug that into the game. So I think ideally you'd have a lot of different types of people testing out the game just to make sure that they're not getting stuck in a certain screen because they're not saying a certain key phrase. Also, again, I'm doing this, just in JavaScript without a game engine or anything, but I think one day when a voice recognition gaming engine does exist, I think that it's going to need a thesaurus built into it so that for any given object, there's going to be all kinds of similar ways to describe it that will just be built in by the game engine to guide the player. There's a certain amount of interactivity with talking with characters in this game. For the most part, you just say talk and their dialogue will pop up. But there are cases where a character will prompt you to maybe answer a certain question or maybe even phrase something in a specific way. I toyed around with it a bit in the latter half of the game, trying different ways to elucidate interactions from the player. There's one screen where a king asks you to tell him kind words, and I looked for a lot of different positive type words you could say, like everything's going to be okay. And so I would look for the word okay, something like that. There's one point in the game where you have to negotiate a peace treaty between two warring kingdoms, these two ant colonies, and again, in the responses, I'm looking for a combination of certain keywords, and so I have a bunch of synonyms lined up, and then with or statements between each, and then and statements with another set of synonyms, so that I'm not looking for a specific phrasing, but I'm looking generally at certain items in the response to count it as correct. I think it's important to have the user's text at the bottom of the screen, and that way they're getting some feedback. A, that the game is working, but B, I think if a player does get to a point where the game's not responding to them, I think it's important that they understand exactly what the game is seeing. And so I think that feedback is important because at this point, voice recognition technology is not flawless. And so if there is some weird interpretation, I think the player needs to know that before they just think the game is broken. In this game, the interactivity is limited to several items, but I did try to make it so that even if you can't pick up every item in a room, you can at least interact with it in some way so that the player is getting some response instead of just silence. And so for any potential object in a room that a player might interact with, I tried to at least have the narrator respond back with no, you don't need that, or something to that extent, because with this type of game, I think the frustrating thing would be just not getting any feedback, which is just be getting silence, because if you're getting silence, you don't know if maybe you said something the wrong way, or if you're just really not supposed to use a certain item. And so it gives a lot of reassurance to the player when they're getting at least some kind of feedback. And I also think that having that level of interaction really encourages the player's creativity. And in the future, there will definitely be fully AI agents, like chatbots, that you can interact with in a natural way. And so that when the player talks with them, they could say whatever they want, and their responses would be generally like what that character would actually say. That's ultimately where the technology's heading, where someone's fully immersed in a theatrical production where they're actually a character in this story. So this program was written in JavaScript. It's an HTML game, so it can be played just straight in a browser without the user having to download anything. I want to make this as user-friendly as possible. The animations on the screen are all groups of 4, so 4 images total for each background animation. Because it's an HTML game, the images on the screen are all actually small. It's not like I started with a really large image and made the pixels look really blocky artificially. These are, in reality, very tiny images just blown up really big on the screen. So it makes it a lot easier for the web browser to load several images all at once without any lag. The walk cycle is 6 images in 4 directions. Overall, I think that voice recognition gaming is going to be huge in the future. I think that eventually most gamers will have played a voice recognition game at some point. I think there's a range of experiences and interactivity that's only really possible when you can control the game with your voice.